Okay, now we are in chapter 6, inner product space. Okay, inner product space actually is a dot product. Okay, a dot product, but for inner product space, we apply to vector more than 3 dimensions. So we call the dot product of vector more than 3 dimensions as inner product. Okay. Okay, dot product or inner product of the vectors is the alternative notation. So for dot product, we use bracket like this. Okay, and for inner product, we use bracket like this. Different symbol. Okay, this is called inner and this is called dot product. Okay. Okay, now if U is given by vector in n dimensions like this with this component, and V given by this component n dimension vectors in space n, then inner product u dot v is given by u1 v1 plus u2 v2 plus dot 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 until un vn, same as the dot product notation. Okay, same as the dot product, but just for more than 3 dimensions we call it inner product. So the operation is still the same as dot product. Okay. Okay, next is orthogonal. What is orthogonal? Two vectors u and v in an inner product space are called orthogonal if inner product of u and v is 0. So if we do operation on the inner product between vector u and v and the result is 0, so we call the two vectors u and v are orthogonal. So this is the definition of orthogonal. Okay, same as we use the operation on dot product. If u dot v is 0, so we say that the two vectors are orthogonal to each other. Okay, example, let u be vectors in 3 dimensions, 3 components we have here, u and v. And if you apply the inner product operation, u dot v, so the answer we have got 0. So since the result is 0, we can say that u and v are orthogonal. Okay, next is orthonormal. Okay, earlier is orthogonal and this is orthonormal. So what is orthonormal? An orthogonal set in which each vector has norm 1 is called orthonormal. Okay, for which vector which is orthogonal to each other, and if each vector has norm 1, we call it orthonormal. Remember what is the formula for norm? So this is like a formula for the length of vector. Okay, if the length of the vector is 1, so we call it orthonormal. It must have two properties. One, it is the two vectors are orthogonal, and next one, each vector has norm or length 1. Then the vectors are called orthonormal. Okay, example, let u1 be this vector, u2 be this vector in 3 dimensions, u3 be this vector, and since u1 dot u2, u1 dot u3 and u2 dot u3 okay is 0, so you can try it out. Okay, so since the inner product, okay, since the inner product of ui uj is 0, therefore we can say that the set of vector u1, u2, u3 is orthogonal. So you must test between u1, u2, u1, u3, and then u1, u2, and u3. So there should be how many? Three trials. Okay, you must try the 3 trials. Then make sure that every inner product is 0. Then only we can say that vector u1, u2, and u3 is orthogonal. Okay, next, constructing an orthonormal set. Okay, earlier we want to construct a set of orthogonal vectors, and now we want to get the orthonormal vectors. Okay, so in order to get the orthonormal set, first we need to get the norm of the vector. Okay, get the norm of the vector. So from the earlier slide, u1, u2 and u3. Okay, from the earlier one, u1, u2 and u3. Now we get the norm of u1, norm of u2 and norm of u3. Okay, remember the formula of the norm. Okay, so once we get the norm of u1 is 1, norm of u2 is 2, and norm of u3 is 2. Then we need to normalize u1, u2 and 3. So how do we normalize it? So we normalize it by getting the formula of normalization, which is u1 over norm u1, which we name it as v1. u1 is the original vector, 0, 1, 0. And norm u1 is earlier, we got it as 1. So we have vector v1 as 0, 1, 0. Actually, it's 0, 1, 0 over 1, which is 0, 1, 0. Okay. The norm of u1 is, construct the formula of the norm u1. So answer is 1. Okay, now next for u2. u2 over norm of u2 is, let's say, v2. Okay, u2 earlier is 1, 0, 1. And norm of u2 is, get the formula of the norm of u2 is 1 square plus 0 square plus 1 square, which is 2. So therefore, v2 is given by 1, 0, 1 over 2, which is this one. Okay, next for u3, normalize u3, we get u3 over norm u3. Okay, so norm u3 is 2. And u3 is 1, 0, 1. So therefore, let v3 be u3 over norm u3. So therefore, v3 is given by these components. Okay. Okay. Since we have that, so we can say that set of v1, v2, v3 is an orthonormal set of vectors. Okay. So remember, orthonormal set of vectors come from the orthogonal set first. u1, u2, u3 is an orthogonal set. So in order to make it orthonormal, okay, from the u1, u2 and u3, we normalize it first by getting the v1, v2 and v3. So therefore, once we get the v1, v2, v3, the set of v1, v2, v3 is an orthonormal set of vectors. And we can also further show that the inner product of vi, vj is 0. So you can test this one. Okay, the inner product of vi, vj, v1, v2, v1, v3, v2, v3 is 0. And also, the norm of each vi, norm of v1, norm of v2, norm of v3 must always be 1. So this one is proven, this one is proven. So it is realized that v1, v2, v3 is an orthonormal set of vectors.